Hi, my name's Dave Matlock, and I'd like to welcome you to the system overview portion of this training video. The Environment 1 grinder pump system consists of several components, which include a tank, a pump, a power cable, and an alarm panel. Environment 1 offers a variety of different styles of pumps, tanks, and panels, but the most common styles that we have out in the field today are the wet well version and the dry well version. The basic differences between these two different types of pumps is how they're supported in the station and how the liquids are discharged from the system. On the basic wet well system, the pump is supported in the station by a stand which rests on the bottom of the tank, and the liquids are discharged through a flexible discharge hose which typically attaches to a slide face valve assembly within the station itself. The dry well version is supported in the station by a top housing which rests on a deck or transition between the dry well portion and the wet well portion of the tank. It's secured in the tank by a latching mechanism, and the liquids are discharged through a stainless steel discharge tube that attaches to a ball valve assembly within the station itself. Different panels that we have are the basic simplex panel. There again, this is the most common panel that we have, but we do also offer duplex panels, Protect Plus panels, as well as a couple of other styles of panels. Regardless if it's a dry well, wet well version, or the wet well version, all of the Environment 1 Extreme Series grinder pumps are a 1 horsepower, 1725 RPM, semi-positive displacement, progressive cavity style grinder pump. Starting at the bottom on either one of these, we have a large diameter inlet shroud where the liquids and the solids come together. The liquids and the solids then pass through a cutter wheel and shredder ring configuration where the solids are ground into fine particles and mixed with the liquids into a slurry state. That slurry will then pass through the progressive cavity portion of the pump, which consists of a stainless steel rotor and a rubber stator. The stator portion is contained within this casting right here, which we call the suction housing. This suction housing is then attached to what we call the motor head portion of the pump. The motor head portion also has an integrated discharge elbow on it, which we attach a check/anti-siphon valve to keep liquids from coming back into the station when the pump shuts down and to avoid siphoning the station dry when the pump shuts off. Located within the motor head, we also have a mechanical seal which acts as a water barrier between the motor head and the motor casting. In the motor casting here, you'll notice that it's a streamlined rib design, and the actual motor stator is pressed into the casting. This allows us to transfer and dissipate heat more rapidly throughout the system. When we designed this pump, we designed it to be rated for 80 psi, or roughly 184 feet of head. The motor itself is a 120 volt or 240 volt multi-tap motor stator. It can be used on either one of those voltage levels depending on the source that's available at the site. On top of the motor casting, we have what we call the control compartment, which contains the control bracket, which basically tells the pump when to come on and off in conjunction with switches that are located within this level sensor assembly right here. Either style pump here, it doesn't matter if it's the dry well or the wet well version, both have the controls enclosed within a cast cover. On the dry well version, we have a top housing that attaches to the top of the control compartment cover. And this is there again what I said, how it's attached and how it rests and is supported within the station itself. There again on the back side here we have the check valve / anti-siphon assembly, stainless steel discharge tube on this format, and we have the flexible discharge hose on the wet well version. The Environment 1 Extreme Series grinder pump is utilizing pressure switches rather than floats to control the on-off operation and the high water level alarms within the system. We've developed a modular design on this pump which is utilizing this device right here, which we call the level sensor assembly. Within the level sensor assembly, we have two switches. The primary switch is an on-off switch, and the secondary switch is a high water alarm level switch. Due to the fact that we're utilizing pressure switches rather than floats, it's extremely important that we maintain ambient pressure within the entire system. The way this level sensor assembly works is we basically set the pump down in the station. The normal off level is going to be approximately right here. So when we set the pump in the station, we're actually capturing a column of air with these sensing bells. As the water level moves up and down, the pressure will increase and decrease within these columns, which will activate or deactivate the switches within the compartment itself. There again, the normal off level is right here, which is approximately 14 inches from the bottom of the station. The normal on level is about right here, or approximately 18 inches from the bottom of the station. And the high level alarm is approximately 26 inches from the bottom of the station. There again, like I said, due to the fact that we're utilizing pressure switches rather than floats, it's extremely important that we maintain ambient pressure within the entire operating system. In order to do that, we're utilizing an equalizer and an equalizer tube. Basically, as the water level moves up and down within the system, the pressure within the columns will increase and decrease proportionally. As that occurs, the pressure switches have diaphragms within them that will expand and contract accordingly with the pressure that's in the columns. As those diaphragms in those switches expand and contract, the pressure that's in this compartment will change as well. So what we've done is we have a barbed fitting that sits on top of the level sensor assembly in which this equalizer tube attaches. That allows the air, as the pressure changes within this compartment, to move back and forth in this tube. This tube is then attached to what we call the equalizer assembly. This equalizer assembly also has a diaphragm that's sandwiched between the two halves of the shell that will expand and contract as well as that pressure changes within that tube. On the sides of the front side of the equalizer assembly, there's weep holes which will allow that air to move back and forth in and out of this portion of the equalizer assembly and into the station itself. Therefore, it's extremely important that our stations are vented. All the vents on this type of station are located at the top of the tank, right underneath this portion of the lid. So as this diaphragm expands and contracts, air will be allowed to move in and out of the well portion of the station and allow proper equalization to occur and maintain ambient pressure within the entire operating system. In this portion of the system overview, I'd like to talk about exactly how the Environment 1 series grinder pump stations work. If you refer to Chapter 3, page 11 of your service manual, you'll find a road map for the 240 volt system. This road map is broken down into a few different sections. If you look in the top left-hand corner, you'll see that's where the main supply power is coming into the system. Over to the right, we have our alarm circuits. And down here on the bottom, we have the pump portion itself.